During this round of tests, I'd replaced IC6003 several times, and in the process I managed to knock off R6024, and when reattaching it, the end cap bent a bit. I thought I was able to reconnect solder to the top of it, but I made a note that I should perhaps replace it with another one if this test fails. That turned out to be an important observation, and I'm glad I made note of it. This resistor is involved in the error compensation feedback loop for the 3.3 volt miscellaneous line, so it's perhaps even more critical than whatever was causing the 2110 error. Since this wasn't even a yellow light of death, it just dies before anything gets registered, not even an error code, I feared maybe the board was killing power supplies, so I tested it on another console and it was fine. So that wasn't it. All fuses and thermistors checked out okay, but I wasn't really expecting it to be them anyway, because if a fuse blew, I would expect a Syscon error code. I'd lost ground and made things worse. But since this behavior was different and I made note of that resistor end cap, I decided to replace it. That fixed this weird single beep issue, and I was back to the 022110 yellow light of death where I started. Lucky. But it was no closer to figuring it out. I felt rejuvenated about troubleshooting this console, so I started down the voltage tree. From oscilloscope testing, I found that the first thing that happens after the 12 volt relay on the power supply is enabled is that IC6003 forms 3.3 volts and 5 volts miscellaneous. 3.3 volt miscellaneous was good, 5 volts miscellaneous was good, so I decided that IC6003 was fine and moved on to those logic gates I had replaced earlier. They were getting 3.3 volts on their input, but we're not getting either of the two signals needed to output 3.3 volts. The logic gate needs the Syscon and buck controller to say it's okay first, then it enables the buck converters. That's part of how the CPU and GPU core voltages are formed. However, since neither the drive on nor Syscon signals were going high, that means something was erroring earlier in the power on sequence before switch 5 or switch 7 could be sent. That's useful because it narrows down the list of subsystems involved. The second thing that happens is IC6020 forms 3.3 volts for the clock synthesizers. So I had a look at it and I found something funny. Apparently when I replaced it before, I accidentally put the new one on backwards and didn't notice. Then, since so much time had passed, I'd forgotten I'd even replaced it. Anyway, I flipped it around the correct way and gave it a test. As I fully expected, it gave the yellow light of death. But there was something different. Instead of an instant yellow